12.3 and over 12? Okay. So it's the cube root of 3 times the cube root of 6. Okay, so this is entertaining. What does it say? Multiply if possible using the product rule. Okay, so these are both cubes. So what can you do with what's underneath? Yeah, so it's gonna be the cube root of 18. Then you ask yourself, is there any way to really nicely break that down? Yeah. Is there? Well, you could do 6 and 3, but it started that way. The point is, you're optimally trying to find a number that is a cube that is a factor of 18.
You can do 6 and 3 and then just break down 6.
9's a square, but it's not a cube, right?
Oh.
The point is, are there any factors of 18 that are cubes? And you can test that by trying to factor it. It's this, correct? Are there any factors that come up 3 times? No, so you just stop there. That's all you do. You can't go any further.
So the final answer is not 3 to the third root of 2.
It doesn't ask you to do that. It just says multiply if possible. This is all it's asking. It's not asking you to convert it to rational. If you want it, are there other ways to write that? Sure. You could write it as 18 to the 1/3 if you wanted to, right? You could write it as 9 to the 1/3, 2 to the 1/3, right? The point is, this is where they want you to stop right now. They just want you to understand the rule. You can glue them together, but that you can only glue them together if you have the same root, right? If those aren't the same root, you can't combine them. So, for example, what they're saying is, like, let's say I had the square root of 2 times the cube root of 7. Can you combine those? No, you're stuck. You're done. I mean, they're not stuck. There's kind of like a negative connotation with stuck, but no, you just can't do anything to that. I think 27 was 27 also up there? Yeah. 27. So 27 asks the square root of p to the 6th over 81, and you're simplifying each radical. Assume all variables represent positive real numbers. What power is square root? What power is square root? To the 1/2. So this is the same as p to the 6th to the 1/2, 81 to the 1/2. Well, do you know what the square root of 81 is? 9. And then what do you do with powers of powers? So this turns into p to the, and then you're done. Good. And then you guys also asked about, is there another one up there? Let's do, let's see, 39. Yeah, I'll do 39, sure. So on 39, the thing that might have tripped you up is it's a slightly larger number, and that's obvious. Do you recognize that as a perfect square? It doesn't look like a perfect square to me. So what are you going to have to do? What did I tell you to do? Yeah, what can you pull out first? 2 and 144. Oh, well, we're looking for a square root, right? So we're looking for a square factor. Did we already find one? Yeah. Oh, sorry. So what is this going to equal? The square root of 2 times the square root of 144. But what is the square root of 144? Yeah, it's 12 root 2. You're done. You're looking for a square factor if you're square rooting. You're looking for a cube factor, right? But is it always easy to see? No, it's not always easy to see. If you're stuck, what should you do? Don't try to sit there like thinking in your head like what's the biggest square. Just go straight into factoring, pull out the smallest, and then you know what? It might just jump out at you. That's a pretty good oval, I have to say, right there. It's pretty good. Oh, and the Olympics, the opening ceremony started.
Today?
Looks good. Okay. 30. Cube root of negative 216 over 125. First of all, can you take the cube root of a negative number? Yes, you can, because this is odd. You can take an odd root. What is the cube root of negative 8? What's the cube root of negative 8? Negative 2. You can take odd roots because negative 2 times negative 2 is positive 4, but then you multiply it by negative 2, you get negative 8. So on this one, yes, it does exist. It is real. So then you have to figure out, are there any cubes in these? You have to do them separately. So what are you looking to do? You can just take that negative out. I'll just tell you that if it's an odd root, you can just make it negative, and it's going to be the cube root of 216 over the cube root of 125. Now, hopefully, you're going to remember that the cube root of 125 is what? Yeah, it is 5, but 216 might be a little harder. Do you know what it is? It is 6. Yeah, it's just negative 6/5. 6 times 6 is 36. 36 times 6 is 216. You're done. You can do the odd root of a negative number. Yes, Dev? 45, sure. 45. Do you guys see Google's doodle today?
Yeah.
Good stuff. Okay. Square root of 30, you're just supposed to simplify this, right? So what are you looking for again? A square factor, right? You're looking for a square factor. It doesn't have it, right? I mean, you go 2 and you get 15, which is 3 and 5. Can you do anything with this? No, so this is the only way you can really state it. There's nothing else to do. Yeah, that is as simplified as it can go. Yeah, correct. I mean, it's not unheard of for the book to do that because sometimes, remember, we had an example problem that was like 2 root 3 plus 4 root 5. How do you simplify that? You don't. You can rearrange it in an arbitrary number of ways, but is there any way to make that definitively more simple? No. You can't factor anything out nicely. I mean, you could. You factor out a 2, great, but that doesn't make it any simpler. And then 51 was the last one people wanted to see. 51 is the cube root of 40. So what are we looking for? We are looking for a factor of 40 that is a cube. It's cube root on this one. It's cube root on this one. It is a cube root. Yeah, I'm just checking. Yeah. So let's just start factoring it. You get red. You get 2 and 20. You get what? 2 and 10. But then you also get what? 2 and 5. So what can you pull out? So this turns into 2 times the cube root of. Do you see the parentheses I used right there? Why do I use those parentheses? Yeah, I want it to be 2 times the cube root of 5. Because 2, this does not equal 2 cubed times like the square root of 5. They're different, right? So just be careful. I really like using those parentheses. I really like it. I did talk about this before, I think, in this class. Sometimes when you see it properly like typeset, you see the radical put like right there. That means the 4th root of 5. That's not how I write it, so it looks really wrong to me to write it like that. It looks like 4 times the cube root. Looks like 4 times the square root of 5. But what's one advantage to writing it like that? You're never going to think it's an exponent, right? That being said, don't. If you see that, it does mean 4th root, though. Okay, I put everything right here. This first one here, can you just subtract them? No, because is it the same thing underneath the radical sign? So let's actually try working on it here. So we have 2 root 20x. What can you break 20 into?
10 and 2.
Yeah, 10 and 2, 4, and you could do, yeah, I mean, it depends on how granular we're going to be. But if we do this, you end up with 2 and 10, 2 and 5. So what can you pull out? So it's going to be 4 root what? 5x. The 5x is still there, right? Now what about the other one here? Is the square root of 45x. That's going to be 3 and 15, which is 3 and what? So it turns into minus 3 root 5x. So now what is it? 1 root. Yeah, you don't have to put the 1 there, so you can just say it's the square root of 5x. Exactly. So sometimes you have to rearrange. Yes?
Why is it that when you factor them out,
yeah,
45x turns like
because I basically you can think of
still 3, but when you take the 2 2's
this is great because what was outside originally here? There was
so
already a
that's
2.
still,
Yeah, there was
add that to whatever.
you multiply it because they've been multiplied together, right? So this right here is 2 times the 2 that came out of the 20 right there.
Okay.
We pulled it.
You put like a 3 in front of that.
It was just multiplied by 3. So long for the ride. Exactly. That's why that was asked in the last class. What about this one? I already talked about this today, but can you simplify that? What do you think? Is there anything that can be done on this one? No. 5 is prime, 3 is prime. There's nothing you can't simplify that. This one is very similar to the one we just did, except instead of square roots, what is it? Cube. Well, 16 we know is 2 times 2 times 2 times 2, but it's a cube root, so we're looking for how many factors to repeat? 3. So that means we can pull out a 2. What already is out there, though? So what becomes the coefficient in front?
1.
So it's going to be 4 times the cube root of 2 minus, and what can we pull out of this? 2 and 27. What's 27? 3, 3, and 3. So we can pull out a 3 minus 15 cube roots of. Oh, do we now have the same radical part? Yeah, so what do we have? 4 of them, and we subtract 15 of them, so we have what? Negative. No, not negative. Wow, negative 11. I did that. I said it was negative 11 cube roots of 2. Absolutely. Good. So the point is, there's nothing too new here other than it's like common denominators. You can't add or subtract fractions unless you have common denominators. Same thing with roots. You can't combine them unless they have the exact same thing underneath and they are the exact same root. Like you could have the cube root of 9 plus the cube root of 81. Can you do anything? Well, cube root of, let's say, 817, something terrible. Can you automatically combine those? No, you need to make sure that they simplify to like the same pieces. Okay, simplify this. I want you to play around with this first before we talk about that. Play around with that first. You want to work on this one? Let's work on the second one. Why the second one?
Because there's
At least there's the 8, right? This would be x. What power would you raise x to? It's x to the 5th to the 1/3. So what power is it? 5/3, and this is y to the 4/3. And you know the cube root of 8 is what? So you have 2x to the 5/3 and y to the 4/3. And what do you have over here? 2x to the what power? 2/3 and y to the 1/3. The challenge is that, can you just add these together?
Wait, why did you get rid of the 3?
Because I just used, you know, cube root is equal, the cube root of x is equal to x to the 1/3, right? All I did was rewrite it. The challenge.
Why didn't you bring it back down? You took the cube root of 8 and made it 2 and put it in front of the x. That's what you did?
Yeah.
Okay.
I just took it exactly right. Now here's the thing: you want to be able to add those together, but can you just add them together like they are written? No, you can't. You could factor out a 2, right? If you wanted to. So I'll just write it like this. And then we'll see one more thing we can do. The challenge is that what you're essentially doing now is you can factor out things. For example, if I had x cubed plus x squared, what can you factor out of both? X squared is going to be x plus 1, right? What about x to the 10th plus x to the 8th? What can you factor out? Yeah, you have x to the 8th times x squared plus 1. Why did you choose x to the 8th?
Because it's the biggest power.
It's the smallest power, actually, right? So my question to you is, can you do the same thing right here? Yeah, what can you pull out of, what power of x can you pull out? 2x to the 2/3, right? Then you get y to the 1/3. What power is x going to be raised to now? It was 5/3, but you pulled out 2 of them. So what is it going to be? 3/3. Ah. What can you pull out of both of these now? It's going to be 2x to the 2/3. Y to the what? Leaving you with what? 1, right? Plus what? X. Because what is x? What is 3/3? 1. So this right here would be the most simplified form, but this is hard.
Is that what
What happened to the y?
the last one?
The last y. Oh, I'm sorry. It's going to be x. Excuse me. X y to the 3/3. Yes, correct. I'm sorry. You're absolutely right. Does that kind of make sense? At least the steps?
Is that what problems are?
No, this is a hard one. This is specifically one that's challenging because you kind of have to break something apart. The idea here is when you notice a bunch of things in common, that should be a key for you to pull something out of it. Pull something out of it. So again, kids, what do you do here? Just make sure you translate that properly. Make sure you cancel properly. And then make sure you have this. The best first step here was recognizing you can combine it into 1 square root. 8/32 is 1/4. That makes things a lot easier. Right there. Yay! 8/32 is what? Is 1/4. You know, don't forget some of that. It's definitely like 10 times 5 to the 1/3 over x to the what power? 2. Minus 3 times 4 to the 1/3 over x to the 3rd. And then you might have noticed that what can you try to factor out? You could try to factor out what? 1 over x to the 2nd. 1 over x squared times, what is it going to be? 10 times what? 5 to the 1/3 minus 3 times 4 to the 1/3 all over x. Is there anything else we can pull out or combine? The 1/3s make it look like you can, right? The challenge is, though, you see that minus sign right there? And also, is 10 being raised to the 1/3 power? Is 4 being raised to the 1/3 power? No. Sorry, is 3. I mean, is 3. 10 is not. Oh, and I just got rid of that. 10 is not, and neither is 3. So you can't pull out that 1/3 power. There's nothing to pull out. What number was that? That was a 3 right there. So is there really anything else you can do on this one? Not really. You could write it as x to the -2 times 10 times the cube root of 5 minus, it's kind of ugly, but this is as good as you can get, over 4 all over x. There's nothing else you can really do to that. This is just an exercise in playing around with